Morning grade 12s. I just wanted to do a bit of a commentary on example 9. Remember that our velocity is the first derivative of our distance or displacement, and the acceleration is the first derivative of the velocity or the second derivative of the displacement or distance. We have covered this previously. It shouldn't feel too difficult. I guess the first part of the question was saying find the velocity and find the acceleration. So they're asking you to find the first and second derivative of the displacement. You're going to be using your product rule, you're going to be using your chain rule. Pretty much things we've done before. Finding the initial speed of the object. Okay, now always in the question you need to go and look and see what they say about where this thing is to start. And it says the object travels in a straight line so that its displacement from the origin x meters, there's a typo there, at time t seconds is given by this. So it starts at the origin. Okay, its speed we're looking for when its velocity is going to be 0. So we've worked out our velocity equation, and we're going to be substituting t equals 0 in there. So when time is 0, it is going at 1 meters per second. All right. When is the object at rest? So something is at rest when the velocity is 0, and it is wanting us to get the position of the object at this time. So we're going to need to do two things there. We need to find out what time or when our velocity is 0, and then substitute that back into our displacement formula to find out where it is going to be when the velocity is 0. So we use our velocity formula, and we're going to put that equal to 0. As soon as we have got a formula equal to 0, we need to look at our null factor law, and we know that e to the negative t equal to 0 is not valid, so we can discard it. So that means that t is equal to 1 second. So this thing is at rest when t equals 1 second, and I now need to find out where it is when t equals 1 second, so I need to substitute t equals 1 into my displacement formula, and I get a value of 1 over e meters. Now, if this is a calculator-free exam, you would leave it as 1 over e meters. Okay, if you had your calculator, you would find an approximate value for that displacement. Now remember, very important, that the sign of that displacement tells us whether it's to the left or the right of the origin. So this is positive, therefore in my answer I'm interpreting that it is to the right of the origin. Okay. Next one says determine when the acceleration is positive. I have an acceleration equation, my second derivative, and I'm looking for when it's greater than 0. And I've got this e to the negative t multiplied by t take 2 is greater than 0. And with the greater than or less than sign, our null factor law doesn't apply. So we can divide both sides by e to the negative t. And I find that for t greater than 2, my acceleration will be negative. But remember, right at the start, they gave us a restricted domain. So this would be the whole crux of the problem, and there will definitely be marks given there for you realizing that the acceleration will only be positive then for t greater than 2, but less than or equal to 5 seconds.